All right, this is lesson 9.1, surface area of prisms. It's on page 356 in your textbook if you're following along in your textbook, or you can get it online. And the surface area of a prism is kind of like the perimeter of a shape. Remember, you get the perimeter by adding up all of the sides, the lengths of the sides. That's always the answer. How do you find the perimeter? Well, I don't even care what shape you're talking about. You add up all of the lengths of the sides. That's what perimeter means. Well, surface area means you add up all of the areas of the surfaces. So if you look at this rectangular prism right here, a rectangular prism is a six-faced shape. Okay, it's a three-dimensional shape, and it's got six faces on it. It's got a bottom, a top, a right, a left, and a back and a front. And you add all of those areas up. When you break it apart, let's pretend this is a cardboard box, and you break it apart, it would look something like this, where here's the top, here's the bottom, and here are the sides. We call the sides lateral faces. Remember, lateral means side, so lateral faces. So we would add up all six of these faces. However, when I find the area of any prism, I find the area of the top, the area of the bottom. Those will always be the same because a prism has two bases, and they're always congruent bases. So they're the exact same size and shape, which means they have the same area. And then if you look, all of these lateral faces really make one big blue rectangle there. So instead of finding 1, 2, 3, 4, 5, 6 areas, I will always find one area for the base. I will write it twice because there are two bases, and then I find the area of one big lateral face. And that's the length right here and the length all the way across the top. Okay? And the length all the way across the top is always the same as just the perimeter of the base. Okay, you would have a W, an L, a W, and an L. A W, an L, a W, and an L. All added together. And we'll see what that looks like in just a second. Looking down at example 1 here, it says find the surface area of the prism. So here's the prism right here. And what they did for us is they broke it apart again. They won't always do that, but just for the first example so we can see what they're doing. And so we're going to find the area of the base. Now, the base is right here, and it's 3 by 5. That's the same as the up here. This would be a 3. This would be a 5, even though it's not labeled. This book does a nice job of not being redundant with its labels. If it doesn't have something labeled, you should be able to figure out what it is. So there's a 3 and a 5. And we find the area of that rectangle, 3 times 5, which would be 15. So the area of the base is 15. And because it's a prism, it's got two of those bases, so it's got 15 and 15. So when I do this, I write surface area of a prism equals, and now big B, like this, means the area of the base. It's different than a little b. If you remember a little b, we use that when we're finding the area of a triangle, 1/2 base times height. That's always a little b because it's a length. A big B means the area of the base. And I write that twice. Big B plus big B. Well, that makes me want some coffee right now. So big B plus, actually I have some coffee right now. So big B plus big B, that's the two bases, plus I want the area of all of these lateral faces, but I'm going to count it as one big rectangle, which is the perimeter of the base. I'll use a big P for that. That big P means the perimeter of the base times the height of the prism. Okay, so let's look what that, let's see what that looks like. So we already said the area of the base was a 3 times 5, or 15. And we'll write that 2 times, because there are two bases. And now we need the perimeter. So we're going to walk around this 3 and 5 and 3 and 5. Okay, so 3 plus 5 is 8, plus 3 is 11, plus 5 is 16. So the perimeter of that base is 16. And the height of the prism is always the distance between the bases. So it's this distance. Here's a base down here. Here's a base up here. How far apart are they? 6. And it's not always just the up-down height. We'll see that in a minute. It's the distance between the bases, okay? So in this case, it's that right there, the 6. And so this is how we'll figure out the surface area of this prism. Remember, we do multiplication first here. So 16 times 6 would be 96, plus 15, plus 15. Now that I'm adding, I can do all of those. 15 and 15 is 30, plus 96 is 126. And units will be inches squared because it's area. It's surface area, but it's area. So let's see, what did they get there? Oh, they got 126 square inches as well. Very good. Now they did it a different way, but we'll use this right here. Now some people will still like to, and they can, just find the area of all of the bases or all of the faces and add them up. You can do that if you want. I find this to be better because this formula works for every single prism out there and you don't have to worry about what the shape is. So here are 2 examples down here for us to work out for the on your own. We'll use the same formula, and I'll write it once right up here. Surface area of a prism equals base, that's the area of the base, plus the area of the base, plus the perimeter of the base times the height, which that gives us the area of the big lateral face that goes around it. Number 1. So remember, I like to write this formula each time. You don't just write it once at the top of the paper. You write it each time, and that'll help you remember what you're doing. Surface area, there we go. And let's look. Well, the base is a 2 by 3. So 2 times 3 is 6. That's the area of the base. We'll write it here. We'll write it again for right here. Now we need the perimeter of the base. So 2 plus 3, that's 5, plus 2, that's 7, plus 3 more, that's 10. So the perimeter of the base is 10 times the height of this prism, which is the distance between the bottom and the top, which is 4. Remember, I do my multiplication first to get 40, plus 6, plus 6. 6 and 6 is 12, plus 40 equals 52. So my surface area is 52 feet squared. Problem much like it over here. We'll rewrite the formula because that's how we roll. Surface area equals base plus the perimeter times the height. And this is an 8 by 8 base. And 8 times 8 is 64. And 8 times 8 is still 64. And now the perimeter. 8 plus 8 plus 8 plus 8, which is 32, times the height, which is the distance between the bases. And then in this case, that is 5. Well, 32 times 5 is 160, plus 64, plus 64. 64 plus 64 is 128, and 128 and 160 would be 288 meters squared. And on page 357, the key idea, surface area of prisms. And here it says, well, to get the surface area, we have to do area of the bases plus the area of the lateral faces, which is what we were just doing. So now it says, what's the area, or find the surface area of a triangular prism? Well, here's where kids sometimes will get a little messed up. So I snagged this little toy from my child here, and this is a triangular prism right here. Notice it's got a triangle on the top, a triangle on the bottom, and they're connected by these rectangles that go around the sides. That makes this a prism. And what sometimes will happen is students will look at this shape and they'll say, oh, well, now the base is this rectangle that it's on because I tipped it. Or now the base is that rectangle. Or now the base is... No. This is a triangular prism. If there is, on a prism, if there is a side, a face, that is not a rectangle, it has to be the base. Because a prism is two bases connected by rectangles. The rectangles have to be the lateral faces. Sometimes we'll have something that's a rectangular prism, in which case all the faces are rectangles. But this toy had a whole bunch of shapes. It has this right here. This would be called, I have no idea, a star prism maybe. And it's got a star on the top and a star on the bottom connected by, you guessed it, rectangles because it's a prism. So what's the base here? A star. What's the base now? Still a star. It can't be anything but the stars for the bases. This would be like the American Red Cross prism. Okay? What's the base on this? Is it this rectangle right here if I set it on there? No. It's this cross. Okay? It has to be because it's not the rectangles. It has to be connected by rectangles. Here's a pentagonal prism. What shape is the base on this pentagonal prism? A pentagon. Hopefully you're saying obviously. Well, what if I set it down on this rectangle right here? Now, is the base a rectangle? Absolutely not. It's still this pentagon. I just stood it up on its end. Here's a hexagonal prism. What is the shape of the base on this hexagonal prism? If you said hexagon, you are correct. Here is a piece of pizza prism. I don't really know what that shape's called. Probably like a semicircle or something. But anyway, I call it a piece of pizza prism. And what is the shape of the base? It's that piece of pizza right there. There's another one down here. It's not this rectangle. It's not this rectangle. And you might say, well, that's not a rectangle. Actually, if we were able to straighten it out, it is a rectangle. It's just wrapped around this. And we'll get to that when we get to cylinders. Here's a trapezoidal prism. Any guesses as to what shape that is on this trapezoidal prism? If you said trapezoid, you are one smart cookie. Delicious. Here is actually a cylinder. It's not usually called a prism, but it's really just a circular prism. It's got a circle on the top, a circle on the bottom, and if we were able to slice this and unwrap it, kind of like you can with like a can of soup, you can cut the label and unwrap the label. It is a rectangle. It's just wrapped around this. So it's a circle on the top and a circle on the bottom for the bases, and one lateral rectangle going around it. Same kind of thing with this, I have no idea, oval prism. Ovaloidal prism, we'll give it kind of a fancy name. But anyway, it's got an oval on the top and bottom with a rectangle. Well, who cares about all of these? We're really just talking about this triangular prism. And I want to make sure that you understand on a triangular prism, the bases are always the triangles. If I stand it up, the bases are still the triangles. If I put it on this end, the bases are still the triangles. If I'm very fancy and I can get it to just like hover on just one point right here, it's still the triangles are the bases, no matter what I do with this, okay? All right, so now let's get back to this problem. So they've got this triangular prism. In this case, they actually do have the base on the bottom, but they didn't have to. But we find the area of the base, which will be, remember, for a triangle, it's 1/2 base times height. So 1/2, 4 times 3. Remember, the base and the height are always perpendicular to each other. They have this little perpendicular symbol. The perpendicular symbol touches the base and the height. Don't get confused by this 5 over here. That has nothing to do with the area of this triangle. It's 3 times 4 cut in half. Okay? So the area of this, the surface area of this triangular prism is still base plus perimeter times height. And in this case, the base is 1/2, 4 times 3. 1/2 of 4 is 2, times 3 is 6. So the area of that triangle is a 6. There's another triangle on the top, so it's another 6. Now the perimeter. So the perimeter is the distance I would walk around this triangle. 3 plus 4 plus 5. And 3 plus 4 plus 5 is 12. Times the height, and that's the distance between the bases. So the distance between the triangles is this 6 right here. 6 times 12 is 72, plus 6 plus 6. So 12 and 72 is 84 meters squared. And what did they get? Oh, they got, way down here, 84 meters squared. What they did is they found the area of the base, the area of the other base, and then 3 rectangular areas. And the problem I have with that, it's a good way to do it, but a lot of times students will miss one of the rectangles, or they'll double count a rectangle. And when you're just finding the area of this total lateral face, it's much harder to get wrong, which is why I do it the way I do. So now they've got a couple that we can work on. Numbers 3 and 4 at the bottom. And we start the same way we have been with the formula. So number 3, surface area of the prism equals the area of the base plus the area of the base plus the perimeter times the height. Now, this triangle, again, is resting on the triangular base. It didn't have to be, but it is one last time. Spoiler alert, this one is not, but we're not there yet. Let's do this one. So the area of the base, we have, here's the little perpendicular symbol. It's touching the 5 and the 12, the base and the height. So 1/2 of 12 times 5, so half of 12 is 6, and 6 times 5 is 30. So the area of the base is 30. The area of the other base is, of course, 30. The perimeter here will be 5 plus 12 plus whatever this is. And it's not labeled here, but it is labeled down here for us, 13. So 5 plus 12 plus 13 is 30. Times the height, the distance between the bases, right there, 3. 30 times 3 is 90, plus 30, plus 30. And 30 is 60, plus 90 is 150 meters squared. Number 4 is much like it, but it's one that really trips students up because students will say that the base is that rectangle, and it's not. It's a triangular prism. The triangle is the base, okay? And one of them is facing you here, and one of them is in the back there, but the triangle is the base. So we still have the same formula. Surface area equals area of the base plus the area of the base plus the perimeter of the base times the height. And we have to do area of a triangle here. So 1/2 base times height. So now I'm saying base, 1/2 base times height, but it's little b, okay? So here's the perpendicular symbol. It's touching the 3 and the, it's not touching this 4, but it is touching that length right there is a 4. It's labeled back here for us. So 3 times 4. And 3 times 4 is 12. Cut in half because it's a triangle is 6. If the front base is 6, that back base also has to be 6. The perimeter of this triangle, 3 plus 4 plus 5 is 12 times the height. And the height is actually this distance right here. Because I keep saying the height is the distance between the bases. The distance between these triangles is this 4 right there. So, times 4. 12 times 4 is 48, plus 6, plus 6. 6 plus 6 is 12, plus 48 is 60 centimeters squared. And to wrap this lesson up, I would encourage you to go into your textbook, if you have it at home or online. There's a video to show you how to get your textbook online. And I would encourage you to work out these odd problems here and check the answers in the back of the book. Especially this one right here, this triangular prism right in the middle. Remember when you do this one that the base is this triangle out front and the other base is the triangle in the back, not the rectangle it's resting on. Okay, so give these a try. This one's a little tricky because it's got the fractional lengths here, but I know you can do it. All right, so give those a try, checking your answers in the back of the book, and then head on over and do your journal page for lesson 9.1, which will be journal page 188. Have a great night.